Now let's say I have to implement stack using linked list. So when I'm saying implement stack using linked list, what does that mean? So first let's see what is a linked list. So here we have a linked list. A linked list has two fields. It has a data and it has a next pointer. Here we are talking about singly linked list. So let's say we have 4, 5, 6, 8 here. Okay. So now this is the head node, or this is the first node, and we have head pointing to the first node. Now what we have to do is we have to implement stack using linked list. So when I talk about stack means last in, first out. So using this particular structure of linked list, we somehow have to implement a data structure such that the last element that is inserted is the first one to be taken out. So we have to write our code such that in this linked list, if we do push operation, a new node is inserted at the top. So here we can have two options for top, this particular or this particular. In this case, let's see what happens if we take this as the top or if we take this as the top. Okay, so let's say we are taking this as top. So what will happen in case of push when we have to insert a new element? So let's say we have to insert 3. So insertion will always happen at this particular end. So now this will be my new top. So insertion is happening from this end, hence the deletion should also happen from this end only. So if we do pop, then this deletion should happen from this end only, which means if I perform pop operation after this particular, what should happen? 3 should be removed from the list. This is one scenario if we are considering head as the top or the first node as the top of stack. If we consider this particular node or the last node as top of the stack, what happens is that if we have to insert a new node will be inserted after this particular node, and if we have to delete a node or if we perform the pop operation, then this node only will be deleted in case we are taking last node as the top. Now the problem here is that here we just have to take care of head variable. Head will always have address of this particular reference. Head will always have reference to this particular node, and the time taken for insertion and deletion will be of complexity O of 1. But in this case, we will have to traverse through the whole list to reach to this particular element for the insertion or deletion, or for that matter for push or for pop. So the time taken to reach to this particular position will be O of n. This is one thing. Another thing could be that I always keep a object variable last, which always points to the last node of the list. So in this case, again, if we have the last node, we will always have to keep on updating last node. In that case, we'll have to maintain one more variable last. So this particular thing looks easy and looks simple. Here we have complexity of O of 1 and we just have one head to be taken care of, and we don't need to maintain any extra variable. So let's proceed ahead that how we can implement stack using linked list when we are considering head as the top. So we have to perform the operation of push and pop. Let's see how we can do that one by one. So now let's say we have to insert 4, 3, 2, 1 in a stack one by one. So first I'll put 4, then 3, then 2, and then 1. So how will I do it? So initially, let's say my list is empty, and obviously if list is empty, I know that if head is equivalent to null. So what will I do? I'll create a new node. So we have node, new node is equivalent to new node 4. Now what is this node? Node is a class which has two variables. So node is a class which is having int data, and we have a next variable which is keeping reference of the next node, and we have a constructor node which initializes the value or the data of that particular node to the data that we pass. So here we are passing 4, right? So as soon as I pass 4 here, this particular constructor gets called. So as soon as we create a new object, new node, and we have this particular value 4, this constructor gets called and a new node with data as 4 and next as null is created in the memory. Say we put this dot next equal to null, even though by default also it will be null. So now this is created in the memory. Now what we have to do is, if you remember in linked list, what we did for inserting a node at the beginning of the list, this is what we are going to do. For push, we are going to insert node at beginning of the list. And for deletion also, we are going to do delete node at beginning. So if you have followed the linked list lecture, this will be very easy for you. So now for inserting node, first I check if head is equivalent to null. If his head is equivalent to null, which means the list is empty, I simply do head equal new node. So now this gives us a list with one element 4. So this is the new list that is created. Now let's say I have to insert 3. So the 3 has to be inserted before 4. So what we will do, we'll create a new node. Again, a new node 3 is created somewhere in the memory. We have to put this in front of this particular node. So I check if head is equivalent to null, which is not the case. Our head is not null here. So in this case, what we have to do is to put 3 in front of 4. What operations do we need to do? So for this particular thing to happen, the next of 3 should point to 4. And right now my head is pointing to this particular node. I have to update it to point to this particular node. So what I will do is that new node dot next is equivalent to head, and head is equivalent to new node. We will see the complete code when we are writing the code in Java, but this is how the push operation will take place in case of linked list when we are implementing stack using linked list. So now let's say I have to insert one more node. I again call push 2. What happens? We check if node is equivalent to null, which is not the case. So now the new node that is created 2, the next of this particular node will start pointing to head. So here the next of 2 starts pointing to head, and now we have to update our head to point to 2. So we update our head to new node, which is this particular node, hence our head start pointing in here. So this is how we can perform push operation using stack. Now let's go on to see the pop operation. So using push operation, we created a list 2, 3, 4, and we have a head pointing to the first node. Now let's say I call pop operation on this particular list or this particular stack. So what will happen? The pop has to remove the element that was inserted last. So 2 was inserted last, so 2 should be taken out from this particular stack. What we will do, this is equivalent to delete head from beginning of the list. Obviously the head is always going to be at the beginning of the list, so I can say delete head or delete first node from the list. So what I'll do is I will first have to always check that if head is equivalent to null. So if our list is empty or the stack is empty, we can't perform the operation. So we simply return, and let's say we print something. Else what we will do is we will keep a data, int data. So let's say in this case I return -1. Data is equivalent to head dot data, and head is equivalent to head dot next. And so our head is updated to this particular node. After this particular operation, our head starts pointing to 3. And now what we have to do is we have to return this data, because in pop we don't only remove the data or remove the element, we also print what was the value of that particular element. So we simply return data. So again, this is going to take O of 1 time. So this is how the pop operation is performed and push operation is performed if we are implementing stack using linked list. Now let's see the code for this. Let's see how do we implement stack using linked list. We have seen the explanation. Let's see the code for it. So we have a class called stack linked list, and in linked list we deal in terms of node. So we need to create a class for node. So we create class node. The node will have 2 fields, data and next. And we also have a constructor to initialize the data. This dot data is equivalent to data, and this dot next is equivalent to null. So now I have created my node, and let's say what I have to do is I have to implement stack using linked list, obviously, and we have to insert 3, 2 and 1. So first I'll insert 3 and then 2 and then 1. This is my stack. So now initially my stack is empty, and we put node head is equivalent to null. Now let's say how do we write code for push and pop. So we have stack main here. We will be calling push method from here only. So let's say I comment this one out. Let's say I have to call push method of stack linked list. What I will do is stack linked list stack list. I'm creating an object of this particular class so that I can call push and pop method from this particular class is equivalent to new stack. Now I'll call stack list dot push and I'll pass the data. So initially the first element that I want to push is 3. So I push 3. Okay, obviously we are getting error here. Let's go on to write this particular method push. So we write down void push int data. The very first thing we will do is we will create a new node. So we create node, new node is equivalent to new node, and we pass the data. So the moment this object is created, the constructor gets called and a new node is created in the memory with data as 3. Now after this we have to check that if head is equivalent to null, which means that the list is empty. So in this case I'll simply do head is equivalent to new node. So after this particular operation, what will happen? We will have a stack here which will have 3 and head is pointing to this particular node. Now I have to insert 2 and I have to insert 2 in front of 3. So what I will do is again call stack list dot push 2, and what happens in this case is that we check if head is equivalent to null, which is not the case. So what we will do is after we have created the new node, the next of new node should point to head. So we do new node dot next is equivalent to head, and I'll update my head to point to the new node. So initially this was my head. Now what happens that a new node 2 gets created, and what we have done is that the new node dot next is equivalent to head. So this is happening and we have head equal to new node. So now my head starts pointing to this particular element. Now let me insert one more element, which is 1. So what will happen? We have stack list dot push 1. So in this case what will happen? 1 gets inserted here and the head is pointing to 1 here. Now let's say I have to perform the pop operation. So when I perform the pop operation, the element that should come out is 1. So let's see that if that is happening or not, and how do we implement pop. So we have, let's say int data is equivalent to stack list dot pop, and whatever element is popped out, we will print that element as well. Now let's write the code for pop. So we have int pop. So we first check that whether head is equivalent to null, which means that the list is empty. So if head is equivalent to null, we simply print list is empty, or stack is empty, better to say, and we simply return -1. So here, let's say we are storing only positive integers. So -1 is returned, which means that the list was full. So in case our head is equivalent to null, we will simply return -1. Now let's say the head is not null. So now let's say we have to remove 1 from here. So in that case, what we will have to do is we'll have to update our head to start pointing to this particular node. And since there will be no reference to this particular node, this node will be deleted during garbage collection. So we simply have to do, we first have to get int data is equal to head dot data, and we update our head to point to the next element, and we return data. So now let's see whether this particular line is giving me the right answer or not. So as you can see that the element popped is 1, and the time complexity in this case for push as well as pop is O of 1. So this is how we can implement push pop using linked list.